When I discovered that people are growing tomatoes and even corn without watering them at all, I thought to myself, well, this must be some dope new invention, this will save the planet. Turns out, rain-fed agriculture is practiced on about 80% of global cropland, and it also accounts for some 60% of world's grain production. Then I thought, yeah, well, the video is pretty much over. And it was. Until I found out about dry farming. You see, rain-fed agriculture has two subcategories: rain-fed farming and dry farming. Rain-fed doesn't use irrigation, but it's practiced in areas with sufficient rainfall, whereas dry farming also doesn't use no irrigation and is in areas with insufficient rainfall. So the plants have to get every last drop of moisture out of the soil. But when done poorly, dry farming can destroy everything, which already happened in the past. So here is how it works. After the rain season, the water gets sealed into the soil, and the farmer starts praying that it lasts. There are a few techniques to ensure it though. First of them is using mulch. It just sits on the topsoil and doesn't let any moisture out. Now obviously using mulch by itself is good, but it wouldn't do the whole trick, and some farmers can't even use it. So the second strategy is even more important, and it is to plant the crops at the right time. This means getting both the moisture as well as the temperature of the soil right. The key is not to wait until the soil dries out to plant, but rather put the seed into immediate contact with the moist soil. And for the temperature, for example, squash, melons or zucchini often require the soil to be between 65 and 75 degrees Fahrenheit to germinate. Getting both of the factors right is often a challenge. Another measure dry farmers take is to plant the seeds deep and with bigger spacing. This technique is also implemented by the Hopi tribe of Native Americans, known for their millennia-old dry farming practices. Here is a quick example.
When I was at Cornell, I was looking at the Western practices of agriculture, and they only want to plant one inch. We're able to plant our corn down 6 to 18 inches at a time, and so therefore it finds the moisture in the tap, and our roots go out about 20 feet too, so that's also amazing. And we have like what they call the elongated epicotyle, which is the growing region of the corn, which allows it to come up from that depth. No other corn in the world is able to do this. We plant on what they call alluvial floodplains, where the water comes down from the mesa and basically floods the field maybe 2 to 3 times during a monsoon season.
Now, what's also interesting is how the Hopi deal with the pests.
And you have to check for things like this on here, like this, see little squash bug eggs on there. So when you find them, you just kind of squeeze them and get them off the plant, because when they get on there, they'll kill the plant. So that's our use of pesticides, just our hands. Sometimes we'll use dog dung early when the corn plants and sprinkle that on there, and that will take care of the rabbits from happening. So everything's natural out here.
But dry farming can also reduce the number of pests and weeds overall because of the lack of humidity. Dry crops don't attract insects, for example, as much. This all means fewer employees, less maintenance, and fewer things that can go wrong. What the scarce humidity also brings is an unexpectedly intense flavor of the dry farmed crops. Now, if you were to dry farm lettuce, for example, it would make it bitter. But for crops like tomatoes or grapes, they grow smaller, but the water stress really makes them pack a powerful savory zing. This is why in France some vineyards are banned from irrigating their crops altogether, as it would negatively impact the taste. And the US might have no other choice but to also ban irrigation, because 60% of US irrigated agriculture relies on groundwater, but the aquifer levels are being quickly depleted, and in about 50 years the American freshwater supply might be only 66% of what it was 3 years ago. Hence, it might be a good idea for all to start thinking about dry farming. But poor dry farming practices can negatively impact the soil, as it happened in the 1930s in the US in the 6-year-long disaster called the Dust Bowl. People were dry farming without paying any attention to the soil's health whatsoever, and combined with big storms, this led to extreme soil soil erosion in the region of the southern plains. Many thousands of people were forced to leave their land. So what are the best practices for the Dust Bowl not to happen again? And what's actually the best soil type for dry farming? I got you covered. So the best soil type is a clay soil with a high organic matter content, because that's the combination with maximal water retention. For example, every 1% increase in organic matter results in as much as 25,000 gallons of available soil water per acre, which is bonkers. But high-yielding corn needs about 600,000 gallons of water per acre. So the 25,000 is noticeable, but certainly not enough. There are actually two types of crops to grow in a dry farming system, either drought-resistant or drought-evasive. Drought-resistant crops, such as sorghum, are able to reduce transpiration and may nearly cease growing during periods of moisture shortage, resuming growth when conditions become favorable again. Drought-evasive crops, on the other hand, achieve their main growth during times of the year when the heat and drought conditions are not severe. Crops adapted to dry farming are usually smaller and quicker to mature than irrigated ones. But to get them growing, we first need to prepare the soil. A good thing to do is to amend it, which means adding extra stuff like minerals to make it better. But amending soil right before planting might burn the roots in an unirrigated system. So many dry farmers amend in the early spring or previous fall. Then dry farmers often use a chisel plow or a broad fork for hand scale operations to break through the plow plan. This helps ensure that root growth is not restricted and helps incorporate organic matter and other amendments deeper into the soil profile. For example, most tillers work the soil to the depth of about 6 to 8 inches. The chisel plow can penetrate the soil to a depth of about 18 inches, creating a pocket for the amendments to fall into. But I've also seen dry farms with a strict no-till policy, and they both work. What the no-till guys tend to rely on instead are cover crops. Cover crop roots can penetrate soil deeper than most equipment and be a very effective way of incorporating organic matter deep into the soil. This may help dry farmed crops access water and nutrients later in the growing season. Also, dry farmers do a pre-plant cultivation right after the initial preparation to prevent the soil surface from crusting and cracking and to manage weeds, conserving soil moisture for summer crop growth. Now, could dry farming or even rain-fed farming practices feed the whole world? Probably not. Because dry farm corn yields, for example, can vary from 85 to 121 bushels per acre, while irrigated acres get about 173 bushels. There may come a time in the future though where there won't be any irrigated acres no more, and instead we might have to farm indoors. Thanks for watching.